from the coherence fabric, then we would not, then essentially I say, I want to invalidate address X. Somebody else might be running X, somebody else's interpretation of what X is different because they're running a different process. And then I would have to send essentially a coherence request that says X in virtual address space this. And even that would be a problem because those that are not in the virtual address space A, like they're running a different process, they will say, oh, your X is not my X, I can ignore it. But the problem is that because applications can actually share memory, for example, you can have memory mapped files, and my application can map the same file into address 1000, your application can map the same file into address 3000. So my address 1000 is your address 3000, right? As far as virtual addresses are concerned. So basically, it would be really, really complicated to do any sort of coherence if we were allowing the coherence to use virtual addresses in any way. So essentially, this way of I do address translation, and by the time I start any coherence conversations with other cores, all of the addresses are physical addresses, is preventing all sorts of problems like that, basically, because like my address 1000 translates into some address X. I tell the caches that I want to invalidate address X, and they basically look up kind of my physical address X needs to be invalidated, and as far as the cores that are receiving the message are concerned, basically they invalidate physical address X. The only time when they kind of again consider the virtual address is when the core actually gives them a virtual address. They essentially do the translation in order to access that physical address. But basically this way the coherence doesn't really have to worry about virtual memory anymore. The only kind of tricky aspect of this is basically, but what happens with virtual addresses that are not even mapped into physical memory, right? Because remember that there is like paging, and there might be pages that actually don't have a physical representation. So when I do coherence, how do I kind of do coherence on those things? But the answer is that you don't really have to do coherence on those, because basically if something is on disk and it's not in memory, if it's not in memory, it cannot be in anybody's caches either. So essentially, something that has a page fault, pretty much, that there are no cached copies of it, because the only things that can be cached are things that are, in the actual physical memory. That also means, however, that when you're paging something out, basically, you're freeing a physical frame in memory, essentially. So what you're doing is really you're copying the virtual page to disk, and that way the physical frame becomes empty, right? Well, it turns out that if there are cached copies that correspond to blocks in that physical frame, it's okay to leave them there. You will put something else there, but as far as these caches are concerned, basically the rights to that new page will just invalidate the stuff that you have in caches and so on. So essentially, if you do paging by basically, kick a page out and write a new page into memory, the act of writing that new page to memory will essentially invalidate all of the copies that existed before, because remember, writes invalidate stuff, and you end up essentially not having a problem. So the problem of basically what happens if I replace the virtual page that is mapped to the same physical page doesn't really disturb anything, but basically you don't have to deal with any virtual memory issues at the coherence level, simply because at the coherence level you're already dealing with physical addresses. So essentially all of the virtual aliasing problems and stuff like that have already been taken care of. Can it cause security issues? Well, yes and no. So basically, the only time when you have a security issue related to coherence is security as in side channel issues essentially will arise if there is a way for one process to measure something that will give them some information about what the other process has, right? So as far as coherence is concerned, basically, if it's really like, essentially I can see, for example, what coherent state my blocks are in, or I can at least measure stuff about it, because basically if I read something and then I try to read it again, I can tell whether somebody read it or not, wrote it or not, simply because my read has a miss, right? Like I brought it to my cache. If nobody has written it, that means I'll have a hit. Otherwise, I'll have a miss, so I can measure time and figure out. So essentially, it's a side channel now, right? But keep in mind that because we are dealing with physical addresses and stuff like that, in order for somebody else to be affected by that, as in I can tell something about their behavior, they need to actually have access to that same physical page, which means basically that they already can read the memory. So me having a side channel information about it doesn't. I mean, that part of memory they can read it. So somehow me having information about the coherence actions on it and stuff like that, is less information than they already had, because they can just read the memory content at that address, right? Now getting information about somebody else's physical blocks and stuff like that is actually possible. So there are side channels that actually consider coherence and stuff like that. But the reason why these side channels exist is because because of directories and stuff like that. So essentially, a directory is a shared resource, and multiple blocks will map to the same directory entry, because the directory cannot hold everything, and it's a set associative structure. That means that in a directory set there will be multiple blocks, and it turns out that when I request something and it needs to be put in a directory, if there is no room in the directory anymore, the directory has to kick out a block from it, as in the information about the block, because the directory can no longer track who has what for that block. The directory is forced to first invalidate all the copies of that, because it can. I mean, the directory is not allowed to forget stuff about things that are in others' caches, right? So the only way the directory can kick something out is if there is no cache copies of that, which means that eviction of a directory role implies invalidating all of the cache copies of that thing, right? So now you can have a side channel, right? You can basically say, oh, I'm gonna, I know in which directory slot the block that I'm interested in the other application would map. I'm gonna basically do software activity that will bring a lot of stuff that maps to the same directory entry, thus kicking out their thing for sure. And then when they access it, I will measure how long my access is to that to my block that maps to the same way take, such that I can essentially tell when they access this. So pretty much you kind of get the same kind of side channel that you would get if you, for example, have like a cache sharing or something like that. And there has been papers on these kinds of kind of directory-based things. But this side channel is not really like caused by the coherence protocol itself. It's basically caused by sharing resources for unrelated things, just like the shared caches are, just like so pretty much every time processes that are totally unrelated to each other are forced to do activity for which they require a resource that is shared by totally unrelated stuff, you have a side channel between those two entities. Cache being one, directories being another, on-chip interconnect being another. So basically, I can tell, for example, when you have a cache miss, simply because if I'm kind of flooding the links in the on-chip network with my traffic gets delayed when somebody else also has traffic, right? So I can see that like nobody else has traffic, nobody else has traffic. Oh, there was traffic. So you can kind of get like an indication for when traffic happens in other cores. Same thing happens with memory controllers. Basically, like if I flood memory controllers with requests, when somebody else has a request, my requests become a little bit slower, so I can tell that, and so on. So essentially, there is a lot of places where basically cores on the chip share resources that allow one core to tell something about the other core's behavior in terms of having a miss or stuff of that nature. And that's why side channels are so insidious. It's really hard to actually get rid of them. I mean, the kind of only surefire way of getting rid of them would be essentially to partition resources in some way. Like, for example, I say, okay, core 0 gets I mean, let's say you have two cores, right? Core 0 gets to use all the resources that are shared in odd cycles, and core 1 gets to use them in even cycles. That way, basically, core 0, whatever it does, it cannot tell what core 1 is doing simply because it doesn't get any information about what happens in odd cycles. But the flip side of that is that core 0 now, even if core 1 is actually not doing anything, core 0 gets only half of the bandwidth of everything, because it's not allowed to use the other cycles simply because using them would allow it to have a side channel. So there is this kind of inherent trade-off between resource sharing and side channel behavior, side channels that exist because of resource sharing. The more effectively you manage resources as a shared resource, the more side channel behavior is also permitted. The more you're trying to prevent side channels, the more you're kind of partitioning resources so that essentially each core gets its own share. But that also means that if that share is totally lying unused, the other cores cannot benefit from it. So essentially, you effectively halve the size of the cache for a core that, let's say, needs a lot of cache, and you're giving the other half of the cache to the core that maybe doesn't really need all of that cache. So there is this fundamental trade-off between basically side channel security and essentially performance, because sharing resources is good for performance typically because there is always kind of asymmetric need among the cores for given resources. Some cores need more cache space, some less, because they're running different applications. Some cores need more memory traffic, some need less because some are more memory intensive and stuff like that. So for almost everything, basically, unless the cores are doing exactly the same kind of thing as the other cores, so that they all have a similar demand for all the resources, partitioning essentially will hurt performance, because those that need more than others will not be able to get it. Okay, so there is a question about the third part of project 2. Try to contact Nolan on Piazza. Let me just, okay. Hoping to walk through my implementation. Oh, yeah, we cannot do that in office hours, basically, because like walking through somebody's implementation essentially would mean that essentially you're discussing your implementation with everybody else, and that's kind of defeating the purpose of having the project actually be done with individual students and not just like everybody collaborates on the same project. So the right thing, I mean, first of all, no one is really not supposed to kind of do that for you. Basically, you can have a specific question about kind of, can I do this, or how do I do this, or something like that, but essentially he's not supposed to pretty much go over an implementation and tell you what the grade would be, or are there any mistakes in it and stuff like that. Because if we did that for one student, we would have to do it for everybody, which kind of amounts to pretty much, everybody submits a project and then we grade it, and then everybody gets to submit a correction for the project and then we grade it and stuff like that. So pretty much discussing kind of like a high level, approach. Yeah, sure, send a Piazza post, and that's I mean, private Piazza post, we can probably do that, but essentially, like, going too much into specific is simply unfair, because we cannot go into really specifics with everybody, and that means that you're kind of getting an unfair advantage. So that's I mean, just making sure we know like what's what level of help is allowable from the TAs essentially. I mean, very good questions that are answerable are basically, okay, in the simulator, where is the part that deals with this type of a problem, or in the simulator, that like not like my code that I did, it's more like the code that exists in the simulator. Why is it doing this at line such and such in file such and such? I mean, pretty much any questions that are about the code in the simulator as it is, or about the what the question is asking you to do, are totally allowable. But as soon as we get into the discussion of why your approach would work or not work, that basically requires essentially you first of all, you cannot publicly discuss it because obviously it's disclosing what your approach is. And second, if we are talking about the details of your approach, then it's also unfair because it kind of would, I mean, like sufficient amount of details would amount to basically us kind of grading your approach ahead of time before submission so that you can change the approach and do that. So that's yeah. I mean, if you have any questions, so if there is a specific question about like what SESC does and why it does it and where it does it and stuff like that, that's a completely allowable question. You can ask it now, but it cannot be like, here's what I'm trying to do. It's more like, can this be done in SESC or why does SESC do this, or where is this type of thing done and stuff like that. Pretty much the question you ask can kind of give like maybe side channel information about what you're doing, as in like you wouldn't be asking this type of a question if we're not doing this, but it cannot be about like, this is what I'm trying to do, is that okay? Okay, I mean, so Nolan and like the rest of the TAs should be, reading Piazza post. So I'm gonna check. I mean, maybe they have been busy with just like trying to get stuff graded and stuff like that because of the the projects having been due and stuff like that. But I'll get in touch with them to see like what's going on. As in like there are some posts, and apparently like they've been waiting for a while. Keep in mind that like during the exam, basically, although like students don't see this, but both the TAs and I are putting out a lot of fires during the exam, because when you have a lot of students trying to take it in all the countries, at all possible times during the day, there is always like, I cannot log in, what do I do? Oh, and the exam is over in like 13 hours and stuff like that. So basically, like in the week of the exam, we were really busy with that, and if any questions are asked during that time, they might kind of slip through the cracks just because like it's been 3 or 4 days of couldn't pay attention to much else other than the exam. So if you've actually asked the question kind of during the exam or right after it, it might be that it's simply kind of somebody saw it, but like I cannot answer this now, and then they forgot to kind of go back to it. But I'll check. I mean, no. So the question is like, should we expect a practice final exam? The answer is no. Basically, the reason why we have like a practice midterm is primarily because you have not seen the format of, as in like how the exam in Canvas works, and so it's more like to get familiar with the interface and the format and stuff like that. So that essentially you don't have to learn how to submit and stuff like that during the exam itself. But for the final exam, basically keep in mind that it's a cumulative exam. So basically, some of the material on the exam will be from the same material that was in the midterm. So essentially, for about 25 to 40% of the final exam, the midterm is a good practice exam for it. The rest of it, you shouldn't really need a practice exam. I mean it's basically the kinds of questions that are being asked and stuff like that are kind of the same kinds of questions that the little quizzes in the lessons are asking, and you're by now hopefully familiar with the format. But so normally we never, I mean, we've so far never needed to release a practice final exam. The only time when we needed to do that was essentially when we've essentially switched from T-square to Canvas mid semester, and had to, like, okay, kind of getting a different environment to take the exam in. So we just wanted to iron out any problems by basically you kind of have like a small exam to go through and stuff like that. Now the course materials should have kind of like a example paper exam and stuff like that. So that's a separate thing. Yes, essentially there is like a practice paper exam basically that asks the same kinds of, I mean, as in the material covered by the questions is the same, but it's not going to be the same format as in Canvas and stuff like that. I'm really reluctant, and I mean, I've never done this in a graduate class, to basically give you a test that is kind of similar to the test that the real final exam will be, because that's really counterproductive. Because if I do that, as in if I give you a test that has a similar format, the questions have to be like sufficiently like tricky, so that essentially you cannot just plug in like as in it cannot be just like if you know it, you know it. Because by giving you the practice exam, I've kind of all the thinking is essentially gone. You just plug into the same form. I mean, there are new numbers, plug them into the same formula, but you've already figured out what the formula should be from the practice exam. So basically the only exams where this is like okay to do is essentially if it's really like there is a tricky question, and then I give you a similar question but with a different trick. But I really don't like to give timed exams, as in there is a limited amount of time, that are kind of tricky, because sometimes students essentially need to kind of for like the really tricky questions, you kind of want to maybe have a night to look at the question, think about it and stuff like that. And I mean, we cannot do that for this kind of exam. So basically the exam can be like this, because essentially you need to do your kind of, for this kind of question, you need to do your thinking during the exam. If I gave you a practice exam that is too similar, then essentially the thinking would be pre-done, and that means that I need to have a question in which the kind of thinking needs to change, and that means a much trickier question. So the kind of the trade-off basically with like giving the practice exam is essentially the more similar the practice exam is to the real exam in terms of kind of what the questions look like and stuff like that, the trickier the questions need to become. So, and I'm trying to really like kind of, if if I don't have to give a practice exam, that also means that I can keep the questions relatively simple, as in if you know something, you can just answer the question. Okay, so we have a few minutes left. So if there are any kind of last questions, then it's time to ask them. Don't like I mean, some students are shy, so they will not ask a question unless they think nobody else has a question. So it's like, okay, we're sitting here, there is no questions, this is the time to ask your question if you have it. Oh, is there a project page for the SESC implementation? So SESC was basically a kind of GitHub based. Actually, was it? So there is a new version of SESC in GitHub. I know that. The problem is, I mean, it's called eSESC, and you can find it. It's been substantially modified since this version of SESC was released. The reason why we are not using that one is that it's even bigger and more complicated than the one we have, and this one is kind of sufficient for the purposes of kind of covering the class materials well. So basically, I'm not sure whether the old version of SESC still has a GitHub page, or whether the kind of GitHub code that corresponds to this version of page is simply buried under the revision history of eSESC. But the problem with like using that as a kind of reference guide and stuff like that is essentially that it's a research simulator, which means people are more interested in kind of basically the assumption on the part of developers is that your architecture because you're a PhD student in architecture who is publishing papers on this, and we don't have to explain like the basics of how the architecture works and stuff like that. And most of the architectural simulators are like that. Basically, most of them. I mean, the only time when the effort of making an architectural simulator is kind of worth it is either if it's going to be used by graduate students to do new things with it, so that essentially each graduate student kind of contributes a lot of development effort for the sake of being able to do their research, or when a company wants to model a processor and thus they kind of write a simulator for it. The problem with the latter is that they will never release that simulator to the public. So essentially the only simulators that we have available for teaching are the ones that were really designed for research, and then kind of adapted for teaching. So that's kind of what we have. That's what most other simulators have. Essentially, teaching is more of a secondary priority for the developers of the simulator, simply because the developers of the simulator are usually PhD students who are actively doing research in that. So they're more interested in kind of implementing that latest gizmo than in commenting the code and stuff like that. So that's that's kind of the now. If you do have questions about like exactly that's why I said, like, if you have a question about like, okay, in function such and such in SESC, I don't understand why the code is doing this, that's a perfectly legitimate question to ask. Basically, I mean I'll explain like any part of the code that even if the TAs cannot explain it, I probably will, because I kind of wrote half of it, or at least I wrote some part of the code, not the cache part. So I cannot really claim much of the cache part, but I've done actually a lot of coding related to it back when I was a PhD student. So I mean, we can explain what's going on. It's just that like adding comments to the project essentially is has never been a priority basically for the developers of SESC, which means the best we can do is kind of add comments to the parts that are relevant for the projects and stuff. I'm probably gonna do that. Actually, I'm gonna sit down and kind of just add comments to the branch predictor files and the cache files and stuff like that we keep using over and over in the project, so that essentially there are comments in the code. Because I'm like really annoyed also that like I mean, even relatively tricky parts of the code have like pretty much no comments that explain why this is done this way. So even when you're doing research and you know exactly what should be done in the code and stuff like that, sometimes it's like, why would you do this? Unfortunately, if you don't put comments in, then that means like you figure it out. I mean, the student figures, like whoever is doing research on it figures it out, does what they need to do with it, and then like 6 months later, somebody else needs to do the same thing, and they're again gonna have to figure it out. So I'll try to just unfortunately for this class it's kind of too late, because that will take more like a month or two. But for the next iteration of the class, I'm kind of gonna just comment basically at least stuff that is relevant to the projects, essentially kind of add comments to just those parts of the code. but if you do have questions, I'm willing to like tell you pretty much anything you want to know about any part of the code. Some of them I will have to figure out, but I kind of know why the code needs to be that way. Just a matter of exactly which aspects of that were actually kind of coded up and which aspects of it are just like assumptions on the part of the developer. So for example, for project 3, the whole thing about the tag being cleared when there is an invalidation, that's why I've kind of warned everybody that, in real hardware, that would not happen. The tag would still be there after invalidation. But in the simulator, for the sake of simulator's own efficiency, they zero out the tag. And thus, when you're doing classification of misses, you really have to, the easy way would be to just check if the tag is still there, but the problem is the simulator zeroes out the tag, so you'll have to essentially track the tag separately, like what it would have been if the simulator didn't erase it when it's invalid. And I know exactly why it was done. It was done to improve the performance of the simulator by about 0.5% at some point, but it creates a lot of problem for everybody else. But, the problem is like when you have students who need to run like thousands of simulations, 0.5% is actually like, hours saved in simulation times. Okay, so if we have no further questions, then we'll conclude these office hours. We'll do the same thing next Tuesday. I'm here, and there should be no problems because I'm back in my office, which means I can actually have a reliable connection and not have to check the voice connection every time and stuff like that. So we'll do this next week, same time, same setup, and everything. If you haven't started working on all of the projects that are still all of the project work that is still pending, it's a good time to start, because we will get to a point where there will be a lot of questions about the final exam and stuff like that. So essentially, like, office hours between now and like a couple of weeks from now are like when you should be asking your project 3 questions essentially. Otherwise, you'll have to compete with the final exam traffic on the office hours. So that said, like, think about the questions, try to do the project so that you have questions about it and stuff like that. Oh, there is a question. Okay, so one last one, just to not leave it unanswered. Would have expected that an instance of SMP cache would contain separate hit miss info for line specific to that instance, but that info seems to be shared by instances. Each instance of the cache does have separate hit miss information. It should be basically that the SMP cache class has the array of counters that it inherits from the cache, from the basic cache, and that those counters are essentially per instance. So pretty much it should be that essentially, and in the report file, I think that there's a reported per instance, which means you probably want to check exactly what's going on. But if you're like, okay, this is what I'm using, like put a private Piazza post about that, and I'll check exactly. Maybe you're just like using the wrong thing, as in there is like legacy code and stuff like that. So it may be that basically what you're using is not even the code that is actually being used by the simulator. Yeah. So what that line does is basically it. Okay. So I would really have to check like the cache is at I should not be there. Basically, it should be that. Okay, I'll definitely put a private Piazza post so I can look it up, because I will now need to look at the code of the simulator, and that's kind of difficult to do when you're on a video call. But again, it's either that this is code that is not really the code that we should be looking at, or my understanding of what's going on in the code is maybe slightly wrong. So okay. Yeah, so basically, I mean, a good way to ask the question is essentially if you map that back to like what the original code had, and then say, okay, can you explain what this code is doing? We can do that. Okay. Thank you again for attending, and we'll talk next week. And kind of I now have some homework to do, so I'll try to do it as soon as I can. Thank you.